This is usually preferred by most as the method. 4.3. Solving systems of equations by, and this is commonly referred to as elimination. This book sometimes refers to it as addition. Okay, so you could have it called either one, elimination or addition. Be comfortable with both. Just keep switching between pens. Let me grab a bit more. Ooh, and the box. Okay. Give you a couple big ideas, and then we'll do the first problem. So, first, just a reminder. These are exactly the same types of problems as 4.1 and 4.2. No differences, no exception. Okay? Just an alternative method to solve. Alright. And so here's the big idea, okay? Or the big idea in red. The big idea is we can add an equal value to both sides of an equation. And it stays true, balanced, equal. Okay, we use this all the time in solving. For example, if I have a problem like x plus 5 equals 10, right? How would we solve that? Yeah, or let's even change this really quick to be x minus 5, so it's addition, not subtraction, right? But yeah, if it was x minus 5 equals 10, we would? Yeah, we would add 5 to both sides of the equation. That's the key, is we know this, right? If we have 8 equals 8, we could add 2 to both sides, and sure, 10 is equal to 10. Right? If we have negative 7 equals negative 7, we could add 100 to each side. And as long as you add the same value to each side, everything's okay. So that's what we're going to do here, yeah?
What does that last word say?
Balanced. We squeezed it in there. It's just all synonymous. It just was like, blah, blah, blah. But yeah, true, equal, balanced, whatever word you want to use to mean that the statement stays true. Right? So here's the example, number 2, by what I mean. Okay? So number 2 is x plus y equals negative 3 and x minus y equals 11. So here's the idea. Okay, this is, new and daring and exciting to some people. So we know that x minus y is equal to 11. Those are exactly equal, exactly the same thing. So instead of adding 5 to both sides of the equation, right, to solve, which is, nice, and we add that to both sides to simplify things and solve. What we're going to do over here is we're going to add this to this side and this to this side, since they're equal. And that will cancel out our y's. Okay? So the key is, because these are equal, we can add it straight up. And so, adding these together, we get x plus x. Okay, we're adding these together is 2x. Positive y plus negative y is plus 0 equals 11 plus negative 3 is 8. Okay? we can add these equations because the left and right are equal. Okay, this is similar to I have 8 equals 8, and I'm adding 5 and 5 to both sides because 5 and 5 are equal. So if I have 8 is equal to 8 and 5 is equal to 5, then I can obviously add those together and get this plus this has to be equal to this plus this. Right? Because 8's equal to 8 and 5's equal to 5, so obviously when I add this left 8 and this left 5, it's going to be the exactly equal thing as if I add its equal value plus equal value and get 13 over here. So that's all we're doing, is we're adding these two that are equal to these two that are equal, and so obviously this side still has to be equal to this side. Okay, just like 8 equals 8 plus 5 equals 5 would stay true and be 13 equals 13. The beauty is, it's called the elimination method, is if we cleverly do this, one of our variables will cancel out. Okay, and I mean, maybe both cancel out, and if both cancel out, we get 0 equals 8, what's our answer?
No solution.
Yeah, no solution. That's not scary, nothing different, same as always, 0 equals 8, no solution. Okay, but usually, if we do this cleverly, and it's a normal problem where they aren't parallel, one of the variables will cancel, and then we can just solve this, okay? So, 2x equals 8, so divide by 2, divide by 2, we get x equals 4, then what do we do with x equals 4? Plug it back in anywhere you want. So plugging it back in, whoops, I'll plug it into the first one because that's nicer. So 4 plus y equals -3 minus 4 minus 4, y equals -7. Write my answer as a point, 4 comma -7. Okay, I'm going to do another example or two before writing the instructions, because sometimes the instructions are a little too abstract if I do it first. So I'm going to do another example or two, so you might be like, whoa, okay, I'm feeling this out. And then I'll write the instructions, and the reason I feel like that's better is then you follow each step. You're like, yeah, okay, that makes sense, that's why we do it. Okay, so we can plug this back in. 4 minus -11 would be 4 plus, or -7 would be 4 plus 7 is 11 for sure. Okay, and 4 plus -7 is -3. So check, we even plug it back in and it works. Okay, so this is a nice method. Let's do another one. The nice thing about that number 2 is everything already lined up. The values were already just primed and ready to cancel out. Things aren't always going to be that sweet. So let's look at a problem like, number 9. Oh, not 9, let's do an even one. So number 10. Okay, so here's number 10. 3x minus y equals 11. 2x plus 5y equals 13. Alright. So, here, we want to get things that cancel out, right? Right now, 3x plus 2x wouldn't cancel, -y plus 5y wouldn't cancel, so we're going to have to adjust somehow. Now what can we do?
Could you multiply the whole bottom one by, like, say, a -1, and then convert it to negative, so the 3x and the no, that would just be 1x.
Yeah. So I like the idea though, multiply this by a number. If you multiply this by negative, 3x minus 2x is closer, we're at 1x. But what we really need is, we really need these numbers to be equal, or these numbers to be equal. It doesn't matter which one you cancel out. So we can do this in 1 step, in 2 steps.
Subtract.
We're not going to do any addition or subtraction yet. First, we're gonna use multiplication or division, multiplying both sides or dividing both sides, usually multiplication, to get them to have the same coefficients, yeah?
Multiply the x, so multiply 3x by 2 and 2x by 3, so they're both 6x.
Yeah, so one option is multiply this by 2, multiply this by 3. Don't write this down because this isn't the way we're gonna do it right now. But that's one way, is think of it like a common denominator. I'm gonna turn both 2 and 3 into the same number by multiplication. So what is the common denominator? 6. So I'm gonna multiply this one by 2 and this one by 3. The one thing I'm gonna say is you want them to be opposites, because when you add them, you want to cancel. You don't want to deal with any subtraction, because then there's tons of negative mistakes. So we're only thinking of this as addition. So instead, we would choose one of these to be negative. So multiply by -2 and by 3. That way this would be -6 and this would be 6. Add them, they cancel. Or exactly the same. Multiply by 2 on the top and -2 on the left. But easier than that, we could just multiply the top. So that would be how to cancel out the x's. Let's look at just canceling out the y's. What could we do?
Multiply everything on top of 5.
Yeah.
Get the y.
Just multiply the top by 5. And you need to distribute to every term. The common mistake is people forget the number. They multiply the x's and the y's by 5 and they leave 11 as 11. I do that all the time. So you'll probably catch me do it at least once. I'm trying to be careful, so hopefully that won't happen. But multiplying it, the same system of equations now looks like this. 15x minus 5y equals 55. 2x plus 5y equals 13. And look, now, lined up right above one another, we have -5y and +5y with that one step of multiplication. So when we add these together now, we get these cancel, and so we get 15x plus 2x is 17x. This is 68. Just divide both sides by 17. That's what a calculator's for. We get x equals 4. Plug the 4 back into something, right? This is 3 times 4 minus y equals 11. 12 minus y equals 11. Minus 12 minus 12. Negative y equals -1. Divide by -1. Y equals 1. The answer is 4.1. So speeding up that latter part, because it's always the same. 4.1, 4.2, 4.3. And then you can plug it back in. 3 times 4, 12 minus 1 is 11. 2 times 4 is 8, plus 5 times 1, 8 plus 5 is 13. Nice, we're good to go, that's the solution. Okay? So we'll do one more together. This one, instead of multiplying one equation, we're gonna have to multiply both equations. Okay, so let's do 22. And then after we do 22, I'll give you some nice general steps to follow. So here's 22, which is, ooh, that wasn't the one I meant. I meant 20. Okay. We'll do 22. I'm crazy. Okay, let's do 9x equals 25 plus y, and 2y equals 4 minus 9x. Okay, so what's the first thing you notice looking at this? Yeah, they're all jumbled up and messed up. So this is where standard form comes in. Standard form is almost useless when it comes to graphing, when it comes to anything. I hate that they even call it standard form, that people think it's useful. But let's just write everything like this. Some x's plus some y's equals some number. For no reason other than now the x's line up and the y's line up. That's it. No, nothing special. There's no logical reason why we need to. So I'm going to minus the y to this side. And I'm going to add the 9x to this side. Okay? Nothing special. Okay, so now we've got same system of equations. 9x minus y equals 25. And 9x plus 2y equals 4. Okay? So what could we multiply by?
You could do either one by -1, and you can get the 9x to cancel out.
Exactly. Multiply either one by -1, and now my 9x and -9x will cancel. So now this becomes 9x minus y equals 25. Negative 9x minus 2y equals -4, and now I can add them. So adding these together, I get these cancel, -3y equals 21, divide by -3, y equals -7, we just plug it back into anywhere, okay, I'll plug it into the first one, 9x equals 25 plus -7, 9x equals 18, divide by 9, x equals 2, our point is 2, -7. So just speeding up those last few steps because they're the same every time. Again, we can plug this back in. Is 18 equal to 18? Yes. Is not 2 times -7, so -14, equal to 4 minus 18. -14 equals -14. Check. Works in both. We're right. Okay. So let's write up some general steps. And I'll put a little example problem to the side. I'll do problem 24 because 24 has a little bit of everything in it, and that's why I like it. The y's don't line up, the x's don't line up, the numbers need to be multiplied on both equations. So 24 has every step in it. Okay, so here's my example problem. Is number 24. And that's 5x equals 4y minus 8, and 3x plus 7y equals 14. Alright, so here are my general steps in this section. And again, this is probably the preferred method by most people for solving these types of problems. So step number 1. Rearrange the equations in standard form, which is ax plus by equals c, so the variables line up. Perfectly. Okay? So my step 1 over here, I'll do my step 1 in red, that's nice. Okay, so step number 1 would be, I'm going to just subtract my 4y from both sides, and we get 5x minus 4y equals -8, 3x plus 7y equals 14. Okay, so first I just need to rearrange it so they line up. Step 2 is the big step, right? Step 2 is choose a variable to cancel out. X or y. Okay. Now, multiply one or both equations by a number such that the coefficients of that variable become the same number but with opposite signs. in other words, the example would be, you'd have something like 2x over 3x, so you would go times 3 times negative 2, and this would become 6x and negative 6x. Right, that's the idea, is you want to multiply it by something, so the coefficients become the same, but one's positive, one's negative. Okay? So let's choose a variable. It doesn't matter what variable in 24. Do we want to cancel out x's or y's? Neither one is easier than the other. So Miguel, which one do we want to cancel, x's or y's? It doesn't matter.
For the x,
Okay, so what's the common denominator between 3 and 5?
15,
Yeah, so how do we get the first one to be 15?
multiply by 3,
By 3? Okay, how do we get the second one to be 15?
by 5.
Yeah, and then we want one of them to be negative, so let's check. This one, 5 times 3 is positive. This one, 3 times 5 is positive, so we need to put a negative sign somewhere. So where do we want it? The other one.
The bottom one?
Okay, put it on the bottom. Yeah. Did you change it?
Or,
Doesn't matter.
okay.
Yeah, okay, we can put it on the top. Yeah, I mean, I think most people choose the top, the reason being, after these cancel, multiplying in the negative, the 4y will become positive, the 8 will become positive, so when you add, just a bunch of positives.
Yeah.
But it absolutely doesn't matter, get the same answer either way. Okay, so that's step number 2 in green. And so now we have, negative 15x plus 12y equals positive 24, and 15x plus 35y equals 7. Okay? So now you can see the x's are lined up. We're able to cancel out the x's. That was the whole reason. Right? That was the whole reason we did step 2, and that's the big new part. That's the special skill there. Okay, step 3 is just add the equations. Okay, so over here, step 3, I'll do it black. Would be just rewriting it really quick. Negative 15x plus 12y is 24. 15x plus 35y is 70. Adding them together, I get, cancel. This is 47y equals 94. Okay. Step 4 is solve. Like chapter 2, right? The bread and butter algebra, just solve like normal. So step 4, divide by 47, divide by 47, and you get y equals 2. Step 5 is plug this into either original equation to find its partner value and write the answer as a point. Okay? So step number 5, I just plug y is equal to 2 back into either original equation, doesn't matter which one. I'll just plug it into the first one because I saw that one first. So 5x equals 4 times 2 minus 8. 5x equals 8 minus 8. 5x is 0. Would we panic when we saw 5x equals 0? No.
Even if the divide by the 5, you get 0 over 5.
Which is? No, well, you're kind of right. It is nothing because what's number is nothing. You just divide by 5, and you get x equals 0. Alright, that's totally normal, totally fine. So our answer is x is 0, y is 2. Right, and I'm always going to write as step 6, check your solution. Okay, just to highlight a common mistake, let's say you did all of steps 1 through 4 wrong, okay? And instead of y equals 2, let's say you got y equals 3. Okay, you did everything in the problem wrong and got y equals 3. Okay? You come back over here, you plug in y equals 3, and you get, 5x equals 4 times 3 minus 8, 12 minus 8, that's 4. You got 5x equals 4, you get x equals 4/5. You go, okay, it's ugly, but whatever, that's my answer. Okay, so my answer is 4/5, comma 3. If I plug this back into the first equation, it will work, because you just plugged 2 into this equation to find its partner. So a problem is, people use the first equation to find the partner value, and then to check your answer, you only plug it into the first one. Okay, regardless of what you got for y. Okay, if you got y as 100, and plugged 100 into this and found its partner value, when you plug that into the first equation, it'll work. The check is when you plug it into both equations. It's really easy to find a point on this equation. I can make one up right now, right? 1 for x and whatever I get for y. Boom, I got one answer. To find the point that lies on both is much harder. So when you check your answer, don't just plug it in the first equation, because lots and lots and lots of points will work in the first equation. You have to plug it into both. So I would plug 0, 2 into both. I would say, is 0 equal to 4 times 2 minus 8, 8 minus 8? Yeah, 0 is 0. But let's check the second one. 0 plus 7 times 2 is 14 equals 14. That's right. Okay? Any point where you use the first equation to get the partner value, when you plug it in the first, it'll work. Okay? So that's just a common mistake that I hadn't highlighted first. Okay. So that's it, right? There's no special circumstances here. If you get 0 equals 0 or 5 equals 5, infinitely many solutions. If you get 0 equals 7, right, ever in any problem in the entire class, if you get 0 equals 7, you just go, okay, no solution, right? There's nothing special. There's no special, like, you need to remember. The beauty is, you just need to multiply by 2 numbers, or sometimes just 1, or sometimes it's already done for you. But you need to multiply so you get the same number where one of them is negative. Okay, I'll do one more example with you, and then I'll let you guys practice this and ask some questions. Okay, so let's see. Another problem would be one like, let's do that one. Okay, here we go. 32. Yeah. 4x minus 2y equals 2. And 2x minus y equals 1. Alright? So, looking at this, choose either variable that you want to cancel. Dan, which one do we want to cancel?
2x.
Alright, so let's cancel out the x's. So what am I going to multiply by?
4.
Where?
2x. 2x.
To this one?
Yes.
Okay, so multiply this by 4. That would give me 8x.
8x.
And so wait, let's take a pause really quick. So what's the common denominator between 2 and 4?
1.
Think of it like a fraction. If I'm adding 1/2 plus 3/4, what would I turn both of these into?
4.
4. Yeah, so I'll turn both of these into 4. So what would I multiply this one by?
4.
No, I have 2 already, I wanna multiply 2 by some number and make it 4. Yeah, so we multiply it by 2. And then we pause and we think, okay, wait a second, that's gonna give me 4x and 4x, so that's not gonna cancel. So instead of multiplying by 2, what am I gonna multiply by?
Negative 2.
Yeah, exactly, there we go. And that's 4.3 right there. That aspect of what am I gonna multiply by so I get a common denominator here. That's 4.3. So now I get 4x minus 2y equals 2. I get negative 4x plus 2y equals negative 2. Add these two together, cancel, cancel, equals cancel. So, yeah, infinite number of solutions or infinitely many solutions to the many solutions. Because these were actually the same equation. You could have seen that if you just multiplied this by 2, you would have gotten 4x minus 2y is 2 and go, oh, yeah, they're the exact same equation. Okay? So that's it. I'll let you guys start this. Absolutely ask questions. In 15 minutes, 20 minutes, half hour, if you guys want me to do more examples, for sure I'll do more examples. Okay?